Hello, I'm Sam.
I'm Mitch,
I'm Drew.
I'm Ravinder.
and this is our senior design motorized training vehicle at NDSU. Our advisor is Dr. Schroeder, and the client is Natalie at Ann Carlson Center in Jamestown, North Dakota.
So just to start with an intro, a background on how we started our project. The research has shown that if a child with disability is keeping up with his peers, the cognitive abilities, at least the cognitive abilities will develop normally, even if their physical abilities can't. And to go with Dr. Cole Galloway is modifying store-bought ride on cars to give children with disabilities their mobility back or even help them strengthen their physical attributes. The problem with this is that the chairs are meant for children from ages 6 and above. Also, they're just standardized motorized wheelchairs. The solution we found was to build and design a power chair that is easily accessible for children from the age of 2 to 4 and which looks aesthetically pleasing for the child and their parents.
Some of the requirements we had were have enough battery power to move the vehicle at least 800 feet. Ideally, apply a daily charge to it and be able to carry a 50-pound user. Some of the clearance restrictions, able to get through a standard doorway, which is about 30 inches, and enough ground clearance to clear standard ramps. And for the supervisor, a master on-off switch separate from the user, and then external controls that will stop and reverse the power chair if the user has a hard time doing that themselves, and then adjustable speed from anywhere like 0.5 to 1 miles per hour. And then for the user, a key switch to turn on the joystick and a left and right mounting positions. And then as far as like environment, mainly it's going to be driven indoors on a flat level surface, possibly carpet, maybe even outside. And as far as some safety and just ergonomical stuff for the child, since they do have like a physical disability, lateral supports in a 90-degree seating angle with a 4-point safety harness to keep them supported, and as far as safety, front and back sensors that will monitor how close the chair is to a wall or object and stop it.
Now I'll be talking about the technical content that we are including in our PowerPoint here. On initial setup, the initial startup of the vehicle, we do have a main power switch that is located on the back PCB case that we have sitting back here. That has 3 positions. It's going to be on, off, and then also charging position so that you can charge the vehicle. We will talk about that later on. The second switch that we have would be the user switch that's right here by the joystick. That switch will allow you to drive the vehicle. That switch itself turns on the H-bridge, allowing you to move the vehicle. Our joystick here goes from 0 to 5 volts in the X and Y axis. 2.5 volts is what it's at when it's centered. When you turn on the power switch and then turn on the secondary switch, you will have to wait until it sees that the joystick is centered to be able to move the vehicle. Another thing that we have added would be a potentiometer that controls the speed of the vehicle, and that will be something that will be used by the supervisor.
And then to kind of continue on with what Sam was talking about with the technical content, we also have 2 front sensors and a back sensor that goes from about 0 to 3 volts for far to close, respectively. And then there's 3 pots that control each of the individual sensors that the supervisor can control to set the trip distance. And then when a sensor is tripped, the user can only go in the opposite direction to which the which sensor was tripped.
Another thing that we want to talk about is also the H bridge. Our H bridge itself gets a 0 to 5 volt input from the joystick. That 0 to 5 volt input controls the motors themselves. With a 5 volt input to the H bridge, you can either switch it from going forward, reverse, or left and right. Okay, and one of the other controls that we have also added would be a supervisor control, which we are using a wireless receiver that is located inside on the PCB board, and then this is the transmitter that we have here. That will allow the supervisor themselves to control the car. You can actually drive the vehicle without having anybody in the vehicle itself. We have a forward, reverse, and a left and right, so that the supervisor can somehow guide the driver without having to be by them. Other things we've incorporated would be LED voltage indicators to show how much charge is left on the battery, and then also, as I said, charging option, which we have a power cord that will plug into the wall so that you can charge batteries.
So basically on the picture behind me, it kind of shows a block diagram of our hardware layout. You can kind of see where all the sensors are coming into the headers, where the pots are coming into the headers, all the headers for the joystick and the fan and the main power, and all the inputs and outputs going actually to the PIC, and then going to the H bridge that's delivering the 0 to 5 volts, the telling it if it's a forward or direct reverse direction, and syncing up with the current with the brakes, and then kind of how the wires go from the base of the wheelchair through that 9-pin connector to the rest of the circuitry.
Alright, so here's some pictures of our PCB. The left picture is of the top side with all the components. The right side picture has all the traces on the bottom. The middle is our joystick. There's 3 LED indicators along with the toggle switch to put power to the H bridge. Top left is our RF receiver, which is matched with the transmitter on the top right. There's 4 buttons. Quite extensive. You can see all the blue headers on the board. There's plenty of I/O. So our H bridge on the top left, mounted to the case. It's actually the cover of the case. Everything's quite crammed into the box. It's our master on/off switch. It's all with quite heavy wire. Bottom left is all the wires ran. It's pretty tight in there. We have put a 24-volt fan in for cooling. Yes, and there's plenty of cool travel stickers.
Okay, then some of the problems we faced through this whole 2-semester design process were in Design 3, the wireless module that arrived actually had the incorrect pinouts that we had on the PCB, so that's why you saw those those two lines on the previous 2 slides were adding in the 2 extra resistors to actually make the supervisor be able to go forward, backward, left, and right. It took a little while for a lot of the parts to actually come in. The PCB took a couple weeks to get milled, and then initially just kind of determining what the client needed and their specifications, and then just kind of the initial starting of the actual concept of how we're going to build this device.
So the lessons we learned by getting towards the end of the semester, we realized that if we started earlier, we would have finished earlier, although that wasn't a as much of a problem because we did finish on time. But we could have saved a few weeks if we did start earlier on certain tasks. Splitting up the tasks between 4 of us obviously helped the project get done a lot quicker. And again, getting towards the end of the semester, when we had much of the stuff piled up, we realized that if we pull all-nighters, we can complete the project on time, which we did.
Hello, I'll be talking about our budget. Our budget was $1,000. We did exceed that. Some of the things that caused us to exceed that budget was the wheelchair base. That really helped us to take a lot of the mechanical issues for design out of our project itself. Another thing that helped us save time, and also was one of the requirements by our client, was the chair itself, not having to build that, not having to find the right one. We did have a couple options, but this was definitely our best option for the chair. And then the last thing was the H-bridge that we purchased that allowed us to not have to create a circuit board for that and figure out how we're going to integrate that into our project. There were a lot of other small things that cost us, which was the joystick itself, and then the batteries. Those were a little spendy, about $100 each. Other than that, all the little things were very minor. As you can see in our budget, we have a few things that we purchased that were not more than $1 each.
To summarize, we found a solution to all the problems discussed in the beginning of the presentation. The first one, designing a power chair for children 2 to 4 years of age with disabilities can use as an introduction to power mobility.
And it works great.
He made a device that is aesthetically pleasing to the children and their parents as well. We did go over the budget a little bit, but at least we satisfied all the requirements.